to a demo that we're going to be doing on Snowflake here. Snowflake has been getting a lot of attention lately as an elastic data warehouse in the cloud. This is going to be the first of a series of videos that we do on Snowflake. This one's going to be just the standard demo that we do just to show the main value props. We're going to do a couple follow-ups that go into a little bit more detail on a couple subjects too. But this is the first one here just to kind of show people what Snowflake is all about, why people are excited about this. And we'll take it from there. So this is the Snowflake user interface. I tell people, pretty clean, crisp user interface. Pretty easy to learn. You can get this down within 45 minutes or so. There's not a lot of hidden menus and submenus and configuration screens and things like that. I just simply went out to a URL that has my demo account here, and now I'm on this warehouses tab here. Warehouses are synonymous with just compute clusters, and I can have any number of compute clusters that I have, any number of compute clusters that I want within my account here. You need those compute clusters in order to load some data and query data. I don't have any right now, and we're going to create some in just a bit so we can load some data. First thing I want to show though is, looking at this databases tab, I can see that I have a few databases in here. An app log database that has some tables in it that are storing some JSON semi-structured data, and I can walk the tree back up here, and I've got another database that has good old sales data and all the usual suspects of having orders and sales and supplier and product and all that good stuff. I have some seed data in here, and we're gonna load this with about 1 billion records worth of data here in just a minute across all these tables here. Okay. Before I do that, I like to show people. You hear about Snowflake, like what is it, right? It's a relational database. It is an analytics MPP database that resides in the cloud, that has been purpose built for the cloud, has a different architecture than other platforms out there. But we are a database, right? And so like any database, I would expect it to have obviously tables. We have views just like any database would. They're not materialized views, they're just regular views. We have schemas like you would expect. We have sequences that you may be familiar with. All the things that I would expect in a database. What is germane to Snowflake are these things called stages. So increasingly, many customers might find themselves having lots and lots of source data or even Internet of Things type data sitting out in private S3 buckets. And if you have that, you can create these stages that allow you to point out to that private S3 bucket. So instead of having to always reference the URL while I'm loading data, I can simply use a much nicer name here, like for example, sales stage, right? When I edit this, by the way, I can see that my AWS key ID and secret key are obfuscated for security. If I want to create a new stage here, it's real easy to do. I just give it a name, and then the URL, the key ID, and the secret key here, right? But if you're a customer that does not already have a private S3 bucket, no need to worry. You kind of already get one with a Snowflake account behind the scenes. Okay. There's this other object here called file formats, and file formats are simply, I can have any number of file formats here to just help with my copy statement for loading data that I'll show you in a second here. Just to let it know what file format is like and what the files might look like that I'm loading, right? Here I kind of hijack the name CSV. I hit edit here. I can see that this is a character separated values file here. It's vertical bar separated. What's the new line character? How many header rows to skip, if at all? What's my escape character and my date and timestamp format? That's in here too. I have some other options, right? I can also load semi-structured data as well. And so if I create a file format, right, again, I can give it a name, whatever I want, and then I can say, hey, is this, character separated files, or is it JSON or XML or Avro? And as I change these different features, I get different configuration options for what I might want to load here, right? So anyway, that's just creating the file formats. But that's essentially it on this databases tab here, right? All the usual suspects. Now, if I want to load and query some data, I need some compute to do that. And this is where I'm going to spin some up on the fly. So I'm going to go to my warehouses tab, and I'm just going to hit create. And I'm going to create a little ETL warehouse here. Again, just a cluster for loading some data. We have a couple different different options here in terms of the type of server I want to use, enterprise or standard. Enterprise just has more memory than the standard does, so I'm just going to hit standard here. And then I can select how many nodes I want in my cluster, right? So we use t-shirt sizes, everything from extra small, which is just a one node cluster, to small, which is 2, and then 4, 8, 16, 32, 64. We can even go to 128, right? Our customers are usually very surprised with the kind of performance they get out of even a small or medium, right? Or even an extra small for that matter. But for right now, I'm just going to select a medium, a little 4-node cluster here for doing some demo stuff, right? The next little feature here is, this is subtle, but very important here. So everywhere else in the cloud, once you provision something, generally speaking, you're paying for it, right? Whether you're using it or not. And we've made Snowflake smart enough to say, listen, after X amount of time, if no one has, submitted any SQL to this database, no one's using it, then we can assume that it's not in use right now. And so let's suspend the compute cluster and thus turn off the meter, which skews the TCO in our customer's favor. The bookend to that is auto resume. So if you have a BI tool or an app or ETL tool that hits this through ODBC or JDBC or Python, whatever, if that cluster were in a suspended state, the auto resume would just automatically wake it back up, right? So I'm gonna hit finish here. And very easily, I just created a little 4-node cluster that I can use to load some data. So let's do that. I'm going to go to my worksheet tab here, and I'm going to load up a little script that I have called load and report. And I'm not going to get encumbered with too many details of this script here. There's a couple just main things that I want to show off. Number one, I've got a little section here that's going to run a series of copy statements. These are anti-SQL, copy statements that are essentially saying, copy into into this table here from this sales stage that we were pointing to before. So I'm loading from a private S3 bucket and looking at the nation folder underneath it, and the file format of everything in there is going to be of all these CSV files. So I'm going to have a little section here that's going to load all this data. Each one of these lines will run sequentially. However, each one of these copy statements will take advantage of parallelism of the cluster. So the more, the larger the cluster I have, the more throughput I have, the more workers I have to start loading data in parallel, right? Then a few other things that I'm going to do down here, namely I've got a series of 22 different queries just to show that, hey, this is anti-SQL, we're doing with clauses and sub-selects, and I'm even doing some windowing functions over here, right, just to show that we're anti-SQL. A couple things that I'm just going to not show in this one right now. I'm just not going to show the parallel unload here. Take this out for now. But the rest of this I'll run, and we can see where that's going to. We're also going to load some semi-structured data in here as well. Okay, so I'm going to hit execute all, and what you'll notice now is over on the right hand side, as I load or as I start running the script, the results are shown over on the right hand side here, right? So I can see the size of the cluster and the number of records I'm loading. Now what's really cool is I can resize this warehouse on the fly and say, for example, instead of using a medium-sized cluster, I want to throw more horsepower at this to get it done faster, so let's use an extra large cluster, right? And so here I saw that I loaded 20 million records in 10 seconds with this medium cluster. It's going to finish the statement that it's currently on here. I loaded this up here. Now the next statement that it starts, loading this product subtable, is actually using an extra large 16-node cluster, and I'll see linear scalability because now I loaded 80 million records in 14 seconds as opposed to 15 million records in 11 seconds, right? So it's pretty much near linear scalability. I can select any one of these lines here, and I can see all the files that I loaded from that private S3 bucket, and if there were errors, or I see that there were none here, which is good. But here I am loading data now, right? Taking advantage of the parallelism here, right? I'm loading the line item table here that I see. I can see what text I'm running right now. This is loading data into the line item table, which I happen to know is 600 million records. So you'll see this kind of go up here. It's processing all that data and loading it into the database. Okay. So while this is happening here, one of the things that I just like to show people, it's going to finish up this line item table here. It's a little bit more than halfway done actually, because I know it's going to end up with 600 million records here. But one of the things I like to show off is something called our zero copy cloning capability. So while these other queries are going to be running down here, I'm going to show off this feature as well. I can see that data is now loaded. It's moving on to running all of these queries here. So we'll come back to that in a second. So uh, uh, zero copy cloning is a really cool feature here. So I can see now, for example, I come back to my databases and I can sort this. I can see all these records that I just loaded into these tables here, just shy of about 1 billion records worth of data, right? Now, if I want to, I think of dev, test, and QA environments and prod environments. Keeping them in sync is not always an easy task. You're duplicating data, you're moving data, and that could take time. Because of Snowflake's architecture, what we can do is we can actually create a clone of a table, a clone of a view, or a schema, or even an entire database with just a click of a button. So, and I can also do that without actually incurring any more storage costs. So, for example, I can clone this sales table here, and I'll call this, my nightly clone, what have you, right, of the sales database here, hit finish. And in a matter of 3 or 4 seconds here, maybe 4 or 5 seconds, it will have created an entirely separate copy of that database, right, with everything in it. I can select it here, and here's all of the data, right? But it is a completely separate copy than the database that we cloned it off of. So, for example, I can drop this 600 million record table. That's gone. I can drop this 150 million record table. That's gone. Maybe drop this 80 million record table. Say, listen, I don't need this stuff. I'm only playing with these other tables here, and that's fine, right? Yet when I go back to databases, and if I look back at my sales database that I cloned this off of, all that data is still here, right? So they are completely separate copies. I can take it a step further, and I can start doing inserts and updates and deletes on any table in this database, and it will not propagate. It will not affect the other clone that we cloned from this, right? And vice versa. So they are completely separate, which is a very nice feature. Okay. I'm gonna go back to my worksheet tab here. I'll see that all these queries are done now. So we loaded all of that data. We ran various queries. I can see, for example, query 9 here has a little meat to it. Looking at those 890 million records or so, bringing together all of that data across a bunch of these tables. This one came back in 39 seconds. Scanning 24 gig of data, and here's the result set down here, the 175 rows, right? Another thing I would just like to show people while I'm here, again, just to kind of get a feel for the kind of performance we're talking about with Snowflake. And again, there are no indexes, no partitioning, no distribution keys or sort keys or vacuuming or analyzing stats, anything like that. The performance is all baked in on this system, right? And it comes out of the box. So to speak, or out of the cloud, as it were. So let me do something simple like, a good old, select count star. Whoops. Count star from line item, right? And of course, when I execute this, it's going to give me an instantaneous answer of there's my count of 600 million records. And of course, it's kind of cheating. It's just using table stats, and I can see here when I ran that statement, it didn't even use any compute, right? It's just using table stats. Well, let me force it to do a full table scan to actually do some work. And so if I did, for example, here, let me give myself a little real estate. If I did something like, L ship mode, which I know is one of the columns in this table, and a count star from line item, good old group by one here, right? Again, nothing's been cached, nothing is indexed, anything like that. I'm going to execute this statement, and you'll see here in actually, that took even a little bit long time here. 2.2 seconds to scan 600 million records in this database, right? Now, you can say, listen, that's great. I don't need, an extra large cluster for that kind of simple workload, right? Well, again, I can resize it on the fly and say, listen, instead of a 16-node cluster, let's go back down to a medium, 4-node cluster, hit finish. And what I'll see now is, again, linear scalability. So I will, for example, here, I'll hit execute again. And now instead of 2.2 seconds, I'm guessing this will take somewhere along the lines of, probably 5 seconds, maybe 6 seconds, 6.8 seconds here. So again, near linear scalability. to go get those 600, scan those 600 million records and come back with the result. Okay. One of the other things that we did here is we looked at time travel. So in this script here, when I loaded this data, this is a really cool feature of our database too. I can select from a table at a moment in time, and it can be as of a timestamp, as of a query ID, or even as of some offset. In this case, after we loaded that data, we said, hey, show me the count from line item as it was 2 minutes ago, and the count that it is, now after I loaded it, and that is actually down over here. So if I look at the show records here in line item, that was this statement right here, right? And I can see I can select from a table at any moment in time. I can actually select from this table as it was at 1:09 p.m. on January 3rd, right? Very easy to do. Again, a testament to the architecture that we have. Another thing that we can do is I can do things like drop table line item, right? And of course, when I drop the table, it'll say that it's successfully dropped, and if I were to try to run a query on it now, of course I should get an error message saying, line item doesn't exist. And usually this is the point where the developer says, oh my god, I didn't realize I was in this database or in production or whatever. I dropped it on an accident. What do I do? Well, it's just as simple as undrop table line item. Bring it back here. It should tell me that it's restored. There it is, and now I can run my data again. All of the data is in there as well, right? You get 24 hours of what we call time travel to do this type of stuff, which is very, very, very nice. So between time travel and the undrop capabilities and the cloning, you have very nice capabilities for built-in backup and recovery scenarios. Okay. Another thing that people really like about Snowflake is the ability to bring semi-structured data like JSON, XML, Avro together with structured data, and I guess more importantly, the ability to natively handle JSON as it is, right? There's no need to pre-process that JSON, flatten it out into tables, do any precursor work. We actually created a data type called variant that stores JSON data natively, and I'll show you a quick example here, right? So I'm going to go to this other tab here. I'm going to log in. I logged in as this other person. I'm just going to create a little cluster to do some work again. Call this like my campaign warehouse. Standard is fine. We'll use a large. That's all good. I just created a little 8-node cluster. Go to my worksheet. I'm going to bring up a little local SQL script here I have again called campaign analysis. Oops, let me open it up here. And really what we're doing here is in fact, I'll execute this and explain it while it's all running here. So we have some data that's sitting in a Twitter database that we have. So we have an API that's reading Twitter data, taking that JSON data and storing it into tables here, right? So one of the things I'm going to do here is I'm going to describe this table called tweets, right? And so yeah, here's this table. It's just a 2-column table. I've got a timestamp here that's called create date, right? Or created at, and then I've got this column called tweet, and the data type is variant, right? And so again, this variant is a data type that we've created to store JSON natively and be able to write SQL against it natively. So if I say, display the last available tweet from the tweets last day table here, just to go get something, right? Here's the latest tweet, so from about a little over a minute, not quite 2 minutes ago here. Here's the timestamp, and here's the actual tweet, and here's how we're storing the data, right? So we're not storing it in just a clob or anything like that. We're not pre-processing anything or flattening anything out necessarily. We are just storing it as is. And now I can write SQL that uses a dot notation that walks the tree of this tweet to go get various elements and tags here and get the information from them. We've even extended the SQL language to use a flatten function that will take items that are in arrays and flatten them out, right? So here's the actual tweet that we're looking at here. If there are any curse words, I apologize. It's live data. But we're getting some data here, right? So I'll close this up. Now, in our scenario, we can say, listen, I can write SQL against this, but wouldn't it be great if I can just, tie this data together with other structured data that I have and do it on the fly, right? And so that's what I'm doing with this with clause that I have here. In fact, I've already run it, and here it is, right? So with this with clause, I'm saying basically, hey, let's go after our structured data set, and notice the notation here. I'm using database.schema.table, so we can actually query across database, which is really nice. So our data lake story is very much intact here, right? But I'm basically saying going after these other tables here. Go get the for every day in January for this product. Let's go get sales revenue data. This other part of the with clause is saying, hey, for every day in January for that product, let's walk the tree and go get that entities and hashtags element out of here along with other data. And bring all of this together, and I'm bringing this together down here in this with clause, right? And so the end result is what we see down here. So for every day in January, I'm looking at Twitter data natively, right, to get the tweet count, and I'm tying that to actual sales revenue, and I can put any BI tool on top of this now to put this into a view maybe, and then have a Tableau or Looker or something like that, query this data and visualize it, right? So that's Snowflake overall. Some of the main features here, some of the main selling points and value props here. I guess it comes down to for many customers, they love the fact that it's zero admin. There's no indexing or partitioning or anything like that to worry about. It is truly software as a service. The speed is incredibly fast. It can scale out very easily by having a multi-cluster architecture. And I can work with semi-structured data natively. Those are the main use cases here. So that'll be the first introduction here. Hope you enjoyed it. We're going to do some other videos that go into some other topics in a little more detail. So thanks a lot.